Hi, this is Rich Bracey for Bracey's A1 Septic to tell you of a great new development. Hopefully you've already seen the video animation, Don't Buy Another Septic Tank Air Pump Until You See This. If you haven't, go ahead and take a look. For those of you who have, you know that over time sludge buildup at the bottom of the sewage treatment plant begins to clog the 1/4-inch holes of the 1/2-inch PVC aeration pipe. The same volume of air being pushed through fewer holes are seen to create excessive back pressure at the air pump, and this causes the aerator to overheat and results in premature air pump failure. I diagrammed a flexible air pipe replacement that you can fabricate from easily obtained materials, or buy complete from me to resolve this issue, as seen here. However, until now there hasn't been a practical way to test your aeration pipe for excessive back pressure, or to automatically protect your air pump from it, nor to answer the question of how much back pressure is too much. Well, no longer. I've designed a safety valve that will both test your aeration system and protect your air pump by venting off excessive back pressure, while still allowing you to use your partially obstructed air system, until such time you can clean the aeration line or install my replacement aeration pipe. But first, how much is too much air pressure? Here you see all the different air pumps from manufacturers such as Blue Diamond, High-Blow, Gast, Seiko, Thomas, etc. They all are built to a uniform standard authorized by the National Sanitation Foundation, or NSF. The standardized continuous pressure rating is 2.13 psi at respective volume outputs in liter per minute, depending on the size of the sewage treatment plant. The air pump model range is normally from 40 to 80 liters per minute at the same 2.13 psi pressure. Why the 2.13 psi? It is based on the weight of water at 0.43 psi per vertical foot. Since the aeration pipe aerates at the bottom of the sewage treatment plant at an average of 4.5 to 5 feet beneath the liquid wastewater level, the math shows this. 5 feet times 0.43 psi per vertical foot equals 2.15 psi of pressure against the airflow of the air pump. This is called back pressure. So all of these pumps are built to withstand this amount of back pressure for many years, and they all are actually built to withstand back pressures up to a little over 3 psi. But under these pressures, the air pump will be working too hard and will become very hot to the touch. The eventual outcome is that the service life of the air pump will be greatly decreased. Instead of 5 to 8 years of operation, the pump may only yield 6 months to a few years before tearing the diaphragms or burning out the pump motor. I have made actual pressure measurements in existing aeration systems almost daily in my work. I have found that the normal range is actually from 1.5 psi to 2.2 psi of back pressure. There is absolutely no reason for the back pressures to exceed these values, except for aeration pipe obstruction. And obviously, the less back pressure, the longer the service life of your pump. So how much back pressure is too much? Anything over 2.2 psi. In light of this, I have developed an aeration safety valve that opens at any excess back pressure over 2.8 psi, which protects and extends the service life of any air pump you may have. And even if your aeration pipe is completely clogged, the back pressure to your air pump will never exceed approximately 3.3 psi. So protect your investment and get this indispensable tool. Now this is how it works. This is a new safety valve that I've designed, and you see that the valve is incorporated into a PVC, 1/2-inch PVC T with a hose to connect directly to your air pump. And you see that this is an existing system with the air pump connected directly to the 1/2-inch PVC pipe. We're going to take that off, and you put your safety valve first. Then you connect up the end of your 1/2-inch PVC pipe coming from your treatment plant, and that's how the system would work. Now to test the safety valve, we're going to put in a pressure gauge that measures PSI and a gate valve to close off the air coming from the pump and create a simulation of back pressure. It's at 1 psi, 2 psi, and as we get to 2.6, 2.7, the air valve begins to vent off air and start protecting your air pump. Now we're simulating that the back pressure is completely clogged. We've got that gate valve all the way turned off, and you see that it doesn't give off any more than 3 psi, which your air pump is easily able to handle without being damaged. So anyway, that's how your safety valve works, and I hope you will enjoy it.